the indefinite integral. So as I mentioned, another way to express the most general antiderivative is used notations called indefinite integral. So what to write here is another way to express the most general antiderivative. Is to use the indefinite integral notations. So that is right. It's just the integral without the limit of integrations. Right? So this is called the indefinite integral of the functions f of x dx. Similar to the most general antiderivative, you could get the antiderivative plus a constancy. The result is a family of functions. Right, just like the most general antiderivative that we see before. So I'm going to go back to the antiderivative that we see before, but in terms of the indefinite integral formula, the common and general antiderivative. Right. For example, the antiderivative of k dx for k is a constant is equal to kx plus a constant c. Right? For k and c are arbitrary constant. Right, so indefinite integral is another way to say that you want to find the most general antiderivative. Sorry, this is supposed to be antiderivative, not derivative. Antiderivatives. Right, so that's the first formula. The second formula is the power rule for antiderivative. So antiderivative of, or the indefinite integral of x to the power n dx, when n is different from 1, different from -1, is equal to x to the power n plus 1 divided by n plus 1 plus a constant c. So this is power rule for antiderivative. The third equation is, the third formula is the indefinite integral of 1 over x dx is equal to ln of absolute value of x plus a constant c. Next one, of course, is the indefinite integral of e to the x dx is e to the x plus a constant c. The indefinite integral of psi of x, or antiderivative of psi of x, is negative cosine of x plus a constant c. The indefinite integral of cosine of x dx is equal to psi of x plus a constant c. Indefinite integral of secant square x dx is equal to tangent of x plus a constant c. Indefinite integral of secant x times a tangent x dx is equal to secant x plus a constant c. Indefinite integral of cosecant square x dx is equal to negative cotangent x plus a constant c. Next one is cosecant x times cotangent x dx is equal to negative cosecant x plus a constant c. Next one is the indefinite integral of 1 over 1 plus x squared dx is arctangent of x plus a constant c. The last one is the indefinite integral of 1 over square root of 1 minus x squared dx is equal to arcsine of x plus a constant c. So this is the formula that you see in terms of the most general antiderivative, but now we switch the notations a little bit and use the indefinite integral. The result is supposed to be the same. So let's apply this formula to some example. So the first example is evaluate the indefinite integral of 4x cubed minus 6x plus 3 over x squared plus 1 dx. All right. So remember, the integral of the sum is the sum of the integral. Integral of the difference is differences of the integral. So I can write this as the integral of 4 times x cubed dx minus the integral of 6x dx plus the integral of 3 over x squared plus 1 dx. The number that stays in front of the variable, that is the constant multiple, so that means you can pull that out of the integral operations. Yeah, you get 4 times the integral of x cubed dx minus 6 times the integral of x dx plus 3 times the integral of 1 over x squared plus 1 dx. Right, so the antiderivative of x cubed, or the indefinite integral of x cubed, is 4 times x to the 3 plus 1 divided by 3 plus 1, minus 6 times x to the 1 plus 1 divided by 1 plus 1. And so the first two integrals, I use the power rule for antiderivative. Right? Plus 3 times the antiderivative of 1 over x squared plus 1 is equal to the arctangent of x. And you don't have to have multiple plus c, just one plus c at the end should be sufficient enough. Right? Then you simplify the calculations, you get 4 times x to the 4th divided by 4, minus 6 times x squared over 2, plus 3 times arctangent of x, plus c. Well, this is x to the 4th minus 3 times x squared, plus 3 times arctangent of x, plus a constant c. I'm going to move on to another example. Find the indefinite integral of theta minus cosecant theta times cotangent of theta d theta. And once again, the integral of the sum is the sum of the integral. Integral of the difference is difference of the integral. So this is equal to the integral of theta d theta minus the integral of secant theta cotangent of theta d theta. For the first term, or the first integral, I'm going to use the power rule for antiderivative. I get theta to the power 1 plus 1 divided by 1 plus 1. What about the second indefinite integral? So negative cosecant theta plus a constant c. So one more time, just one plus c should be good enough. And this is equal to theta squared over 2 minus cosecant theta plus a constant c. So next example. Find the integral of 2 times square root of x minus 1 over square root of 1 minus x squared dx. So this should give me the integral of 2 times square root of x dx minus the integral of 2 over square root of 1 minus x squared dx. So for the first integral, and of course the second integral as well, the 2 are the constant multiple. Pull that out of the integral operations. You got 2 times the integral of square root of x dx minus 2 times the integral of 1 over square root of 1 minus x squared dx. For the first integral, I would like to change square root of x into a power function. So square root of x become x to the 1/2. And for the second integral, what is the integral of 1 over square root of 1 minus x squared going to be? Right, so the first integral can be written as 2 times integral of x to the 1/2. I'm going to take that, going to evaluate that a little bit later. But the second one is 2 times r psi of x. Now for the first integral, you use power rule for antiderivative again. You get 2 times x to the 1/2 plus 1 divided by 1/2 plus 1 minus 2 times r psi of x plus a constant c. And of course, you simplify your calculations. You get 2 times x to the 3/2 divided by 3/2 minus 2 times r psi of x plus a constant c. Then when you divide your fractions, you multiply by the reciprocal. You get 2 times 2 over 3 times x to the 3/2 minus 2 times r psi of x plus a constant c. This is equal to 4 over 3 times x to the 3/2 minus 2 times r psi of x plus c. So the next example is a little bit more tricky, but let's see if you can tackle it. Okay, so evaluate the integral of 1 plus cosine square of theta divided by cosine square of theta d theta. So the next example is a little bit more tricky, but let's see if you can tackle it. Okay, so evaluate the integral of 1 plus cosine square of theta divided by cosine square of theta d theta. This is a fractions, and there's additions or subtractions in the middle. So what you can do is actually you separate these fractions into 2 smaller fractions, right? So I separate this into 1 over cosine square theta plus cosine square theta over cosine square theta. So cosine square theta cancel out. You get 1 for that, right? And this one is 1 over cosine square theta plus 1 d theta, of course. Right. So that means from this point, you can see that the integral of the sum is the sum of the integral. So you have the integral of 1 over cosine square theta d theta plus 1 the integral of 1 d theta. So the integral of 1 d theta is simple enough. Right, so that's the antiderivative is equal to theta. But for the first integral, if you recognize, go back to pre-calculus, right? 1 over cosine theta is equal to secant theta. Right, so a side note here, 1 over cosine theta is equal to secant theta, or 1 over cosine squared theta is equal to secant squared theta. So that means, right, so the first integral is the integral of secant squared theta d theta plus the integral of 1 d theta is theta. It's the integral of secant squared theta equal to tangent of theta. So tangent of theta plus a constant c.